Let's switch and start talking about the next interface that we mentioned, which is the interface of the disposable to the novel electronics that are powering these things or sensing different things. Things are connected. So, in your experience, like electrifying these consumables, I guess what are some of the examples of functionality that you're seeing added to traditionally all disposable medical devices?
So I think the first place where electrification of disposables happened is really in temperature measurement because the cost of those sensors has been driven so low by the ubiquity of temperature sensing, and how little you need in terms of hardware to get reliable temperature measurements. So temperature sensing is a big one. Measurement of other physiological conditions in a hospital environment or otherwise is also super common for electrified disposables now. Even things like consumer products like vaporizers, which obviously is not a medical product, but because they are so commonly used, these disposable vaporizers, they're driving down the cost of things like disposable batteries, disposable circuit components that go into those disposable temperature measurement sensors. And then I've also seen flow sensors, memory chips on products such as EEPROM chips and things where maybe you have a variety of different disposables that look very similar. One example of a product that Keytech has spent time working on that uses something like that is a product for combinational drug therapy. And in that case, you've got a variety of things that may fit together, that look very similar, but you don't want the user to have to think very hard about what is in each one of those and how they fit together. And so if you can put some intelligence in your disposable that makes it easy to identify by the durable part of the device, that can really streamline the process and reduce risk for what you're trying to design.
So those are some examples of functionality that are being added to consumables. But the topic we're covering today is the interface. So when you talk about these functions are being added, these components are being added, but what is it about the interface between the disposable and these electronics that you need to look out for?
So it's really a different kind of electrical connection than what we as engineers are used to in other areas of our devices. So, the most common thing on the inside of a device is a PCB mounted connector that goes directly to your electromechanical component. But those kinds of connectors that are going to be board mounted are typically not appropriate for the kinds of interfaces to disposables that we're talking about here. And so you need to think about different things like how the user will interact with that connection, whether it is easy to hold in their hand and easy to manipulate. The number of connections involved. You may need just two conductors for something like a temperature sensor. You may need four conductors if you are, for example, driving some piezoelectronic element and you want to have some sensor alongside that to either sense the presence of liquid or just get a continuity check to sense for the presence of that disposable connected to your product. There's a good example of a product that I've been working on very recently in that we're using a piezoelectric misting transducer to mist some saline. And in that case, we have four conductors. And so that has driven us away from, something like, for example, a pin and socket connector, where if you've got four connectors, there's some difficulties with tolerancing among those different pins, and so you typically want something with either a little bit more compliance or that has those four connectors kind of in the same annular design. So something like an audio jack or an amp jack is something that we may end up using for that, just because it's one connection that the user needs to insert, but it has four uh, conductors along the OD of that connector. Um, some other constraints that you're going to think about in that case are things like ingress protection. Your internal connections are not going to need the same kind of ingress protection that you have on the outside of the device. Cost pressures, which are going to be different for your single-use disposables versus your multi-use disposables, but there's a lot more cost pressure for something that's disposable than there would be for some of those inside the device connections. And then cleanability, especially in a multi-use disposable case. you may need to wash that disposable with soap and water a few times before you replace it, and so it can't be something that's going to corrode in that case.
But great. No, those are all, yeah, it makes you wonder why you'd want to add all this complexity to these consumables, because you're just introducing, these compounding effects of functionality and interfaces, particularly on the electronic side.